Hello all. Today we are going to discuss a topic that is very important, but not a lot of us want to think about it. We're actually going to talk about sewers and septic systems and a little bit about water treatment. So wastewater is what we normally call sewage or sanitary sewage. Wastewater systems are kept separate from stormwater systems. Wastewater systems bring sewage from customers to treatment plants. They consist of a sewer service, which comes from a building to a municipal line, then the lateral lines, which collect the sewage from services and bring them to the trunk lines, and the trunk lines, which are the largest lines, bring the sewage from the lateral lines and they bring them to the sewage treatment plant. So what do we need for sewer design? We need several things. The first thing that I have on my list is a topographic survey. A topographic survey is a survey that includes elevations. And there is that old saying that sewage only runs downhill. So we have to know which way stuff is running so that we can make sure we design our system properly. In addition to the topographic survey, we also need property surveys in the areas that we are dealing with. Municipal lines in general cannot be on private property. The only exception to that is if there is an easement that goes along with that installation. So in general, though, public utilities are in a public right-of-way. They are not on private property. So we just have to make sure that we are not working where we should not be. Then we also need to know the quantity of sewage. The pipes have to be sized to carry the appropriate quantity away from the customers and to our sewage treatment plant. Then we also need to know the depth of the sewers that we are connecting to. That becomes important for a number of reasons, such as if you want to provide basement sewer service. In a lot of areas, like in my personal house, I have sewers, but the sewage service line actually is about 3 feet up from the basement wall. So it would mean that I really cannot provide basement service here. If I wanted to install a sewer in the a bathroom in my basement, I would have to then have a pump to get it up to the service line. So quantity of sewage. Roughly 75% of water use becomes sewage. If we don't have water usage data, we're going to assume 100 gallons per capita per day. And peak flow can be assumed to be 4 times the average rate. So to determine the flow rate, multiply the area by the population density by the flow rate. Now, you might ask, where do I get my population density from? That is something that is available to us online if we look up census data. So that's one of the reasons why census data is actually important, because it helps us to figure out how many people are living in a certain area, and that could then help us with figuring out how much drinking water I need to supply there and how much sewage I need, sewage capacity I need there. So gravity sewers, most of our sewers flow by gravity. And that's why I mentioned the importance of a topographic survey to start off with. So they must have a slope to carry the sewage away. They must be sized adequately to carry the sewage away, and they must be in an accessible location. In general, that's why the sewers are in the street, is because those are accessible to me as a municipality, because I could always basically work in the street. When I have an easement and the sewer ends up being on private property, there are actually conditions that go along with that easement that the people that are buying the property have to abide by. Now, prior to coming to the college, I was a town engineer, and I had a situation where, because of the slope, there was a sewer line that went behind a whole neighborhood. It went behind their properties, and somebody decided to build a garage over the sewer line, one of the homeowners, and the town actually had him tear down his detached garage, because with the garage there, we did not have access to the sewer in case there was a problem. So we must have access to these sewers so that we can maintain them, keep them clean and flowing, and then if there is a problem, get in there and repair them. So this is actually a copy of a Manning formula pipe flow chart. This is something that is used to size sewage pipes. Now there are, of course, computer programs that will do it, but this is actually kind of an easy way to do it, because if you have any 2 points of this information, then you could then design your pipe and size your pipe. So on the left-hand column, it actually has the flow in gallons per minute. So if I know my flow, and then let's say I know the slope that I'm installing this pipe in, I could then draw a line between those points, and then I could actually size the pipe. Now, I'm going to just remind everybody here that this chart has certain sizes that are not actually in common usage. There is actually, I guess, a 5-inch pipe there, and honestly, that is not a common size for pipe. So if you are between common sizes, the best practice is to size up and go up to the next, the next larger size. So if my line said, oh, I need an 11-inch pipe, there are no 11-inch pipes available, but there is 12. So I would then put a 12-inch pipe in, because that is something that I can get. What if you have to pump? So if you have to pump, that means that you're lower than either the sewage line, the sewer line, or there's some other reason why you might have to pump, but it's generally because you're lower. And there are 2 things that are done in that case. And one is something called a grinder pump. And there's a picture there, and I have another picture available to you guys on the next slide. I thought I put it in. That's a little more detailed. But this has a little pump in the bottom, and it grinds up whatever sewage is there, and then it forces it up into a higher pipe. Also, if the whole neighborhood is actually lower than the pipe they're trying to tap into, you might have a central pumping station where, let's say, 10 houses on a cul-de-sac will all go into, by gravity to a central pumping station, and then there will be a pump there that then pumps all of their sewage into the municipal sewage system. So here is a picture of a house. This is kind of showing in the middle. You see the roadway. You have a house that's lower than the roadway, and they have to pump. And then you have a house on the other side of the road, which is higher than the roadway, and they don't have to pump. They could go by gravity. So Westchester County has quite a few neighborhoods that are actually like this, because we have a lot of hills. So one side of the road may be above the grade of the road, and the other side may be below. So the people below would need a pump to get up into their sanitary sewer. Problems that we face with sewers. One is something called inflow and infiltration. And what that means is that storm water is entering the sewer. In the early 1990s, Westchester County actually had a big project where they went around to the municipalities and had them find out where inflow and infiltration was coming from and basically try to eliminate 25% of that inflow and infiltration. And that was done because that extra stormwater going in during the times of the storm was going over the limit of capacity of the sewage treatment plants. So, and that could come in from various things, illegal connections. In some areas, people might have drains tied into the sewer, which is, again, not legal, but it does happen. Also, our systems could be old and there might be cracks and damage in areas that are allowing stormwater to get into the sewer. Then we also could have structural damage to the pipe, and this can sometimes be repaired by relining pipe. I am including a couple of videos with this week's assignment, and one of them actually shows how we can reline a pipe while it is in the ground, so we do not have to dig to do that repair, and that ends up being a less costly repair because we don't have to dig and go down and dig in deep into the ground and replace a broken pipe. Then sometimes I might have a sewer that has collapsed or has dips in it, and in that case I do have to dig it up and replace it because I cannot line it if it's collapsed. So once the sewer, I mentioned we have sewage treatment plants, but once the sewer gets to the sewage treatment plant, why do we do this and what happens? And the reason that we do it is because we don't want to discharge wastewater into freshwater supplies. So this all came about and started with the Water Quality Act of 1965, and then also the Federal Water Pollution Control Act amendments of 1972. And then we also have the National Pollution Discharge Elimination System and the Clean Water Act. So the reason that we treat wastewater is that even though untreated sewage is about 99.9% pure water, that's that 0.1% that we are concerned about. And there are things in there that, we should not be drinking. It's not safe to drink, so it's not safe to discharge into our environment that way. So the total amount of organic materials is measured in biochemical oxygen demand or total suspended solids. So average biochemical oxygen demand is about 200 milligrams per liter, and the average total suspended solids is about 240 milligrams per liter. Raw sewage also contains plant nutrients, nitrogen, and phosphorus. And raw sewage can contain coliform bacteria. You guys may have heard of outbreaks of something called E. coli, and that is a type of coliform bacteria. And if we actually consume it, it will make us sick. So all of these have to be removed before it is released to wastewater. So the three main categories of wastewater treatment are primary treatment, secondary or biological treatment, and tertiary or advanced treatment. The type of treatment that we are dealing with and that we have to use is related to where we are discharging it. Tertiary treatment plant, again, advanced treatment, the water that comes out of that treatment plant is actually safe to drink in many cases. Some years ago, I visited a advanced treatment plant that was down in Florida. I was there for an engineers conference, and they took us on a tour of this, at the time, brand new treatment plant. And at the end of the treatment, at the end of the tour, they actually had paper cups, and they said, "Oh, you're welcome to take water from the discharge and drink it." I will be honest, I did not. And the engineer in me said, I know this water is clean because I just saw all the treatment that was going on. But the person in me still said, this was raw sewage a little while ago, and I really don't want to take a chance of drinking it. But the reason that they had the tertiary treatment was that it discharged into a stream that was actually part of the drinking water system of another municipality. So they had to make sure that the water was safe to drink. So here I have a little drawing of wastewater treatment, and it basically has the raw sewage that comes in, and then it goes through some screens, and then it goes through the communitor, and then the grit chamber, right, which then a clarifier, and then that's really the primary treatment. And then it goes into our secondary treatment where we have an aeration tank, and then we also have a second clarifier, and then it is disinfected. Similar to drinking water, generally chlorine is added as a disinfectant, and then it is discharged to surface water, or it could then go into the tertiary treatment if needed. So in our environmental problems class, if you guys take that that are taking civil tech, I always do a field trip in that class when I teach it. This semester, there will be no field trips because of the COVID situation. But one of the field trips that I have taken that class on has been to wastewater treatment plants. There are several of them in Westchester County, and I have taken students to go see how this process happens. I will tell you the interesting thing that now all of the wastewater treatment plants really, really do not like the fact that the disposable wipes flushable wipes have become popular, because all of that gets stuck in their screens, and there's a lot of extra maintenance that has to be done because of the use of that. So hopefully when things go back to normal, we can again take a class on a field trip so you can see that. But because we don't do that this semester, I'm also including a few videos that you could watch of wastewater treatment plants. So what is a septic system? Some of you here may have a septic system at home, and it is basically an on-site wastewater disposable system. The two main components are the septic tank and the leaching fields. So when do we use them? I mentioned that some of you may have them. Generally, they're used when there is no available public sewer. And generally, that ends up happening in less densely populated areas. And so if you live in a less densely populated area, somewhere where maybe, the houses are an acre or 2 acres apart from each other, properties are 1-2 acres and the like, you may have a septic system. And due to current regulations, you're required to have an area for a second set of fields in case the first set fails. So generally, you'll need about an acre of land for a new septic installation. So I mentioned in Westchester County, are areas that are like that, because again, if the property is that far apart, the municipality may not consider it cost effective to install sewers, but so you'll be forced to have a septic system. And I know there are areas in Greenburgh that have septic. There are areas in northern Westchester. I'm up in Yorktown, but Yorktown, Cortland, there are many areas that have septic systems. So what I have to do before installing a septic system is I have to do a site evaluation. The first thing I look at is the soil conditions, right? I'm going to run a test, which I'll explain in a few minutes, called a percolation test, so that I could see how much the water drains into the ground. Also, I have to look at the slope of the land again, because water tends to flow downhill. I also want to look at the groundwater conditions. So if the water is right below ground, groundwater is right below ground, then I really can't add my septic to it because it won't go. Also, my potable water source locations, which means if there's any wells on the site, I have to make sure I'm far away from a drinking water well because of the fact that I don't want cross-contamination. And then surface water locations, any ponds or lakes and that kind of stuff. And then other considerations on the site, like structures that are there already and or rock formations and other things that I have to know before I actually build my septic system. So I mentioned the percolation test, and basically the way we run these, we dig a test hole about 8 inches in diameter and 2 feet deep. Then we fill the hole with water, and the water will hopefully drain out of that hole. And then it's repeated until a constant rate of drop is observed. And then I refill the hole, and then I measure how long it takes for the water to drop 6 inches. And the perk rate is determined in minutes per inch. And what that percolation test result does is allow me to figure out how much fields I need, how much area of fields I need. So this is actually the chart that's used for sizing the fields. What I want you guys to notice, and I mentioned I'm working in minutes per inch for my perk rate, but the area is given in square footage per bedroom, or square meters per bedroom. So this does not count the number of bathrooms or the number of the square footage of a house, but the number of bedrooms. This comes about because in Westchester County and most of the more rural areas, the way the population is estimated in a house is based on basically the number of bedrooms plus 1 is generally what we design for population-wise. So if it's a 3-bedroom house, we're going to assume that there are 4 people living there. So the population has more to do with the amount of water I'm using than the actual number of bathrooms, right? Because if I have 3 people living in a house, I am, cooking for 3 people, I'm washing for 3 people, 3 people are taking showers and baths or whatever. But if that house has 4 bathrooms for some reason, I'm still only using water for 3 people in general. So that's why that's done by bedroom and not by the number of bathrooms. Yeah. Also, similarly, a lot of the older houses, when we were looking for a house with my wife, we actually saw a couple of older houses that were 4-bedroom houses that only had 1 bathroom. We still had at that time, my kids were living at home, so there were 4 of us in the house, and whether it was 1 bathroom or 2 bathrooms, there's still 4 people in the house. So this is what a septic tank looks like. So I have an inlet coming in from the house, which is where my sewage is coming in, my wastewater from the house is coming in. I have a layer of sludge on the bottom. I have my liquid effluent, and then I have my scum layer. The purpose of the tank is to give solids time to drop out of the liquid, because the fields are not really designed to, or they're not designed to take solids. They're really designed to take liquids. So that's also one of the reasons why septic tanks have to be maintained and periodically pumped out, because that level of sludge, if it rises to the point where it gets into the outlet, then that will also damage the fields, and then that will be a very expensive repair. So this picture, and you can see it's definitely not in a congested area. There's a lot of land around that house. It shows the pipe coming out of the house and going into the septic tank. Then the pipe goes there, leaves the septic tank, and goes into my fields. First it goes through a distribution box, and then it goes into the fields. So you see those fields are laid out, and they actually will be filled, and then the water, once it gets in there, will go into the ground. Now, I have some video links that I will be placing in Blackboard, so please look at the links for a little more information. And if you have any questions, please go to the discussion board and post your questions. And also, you guys could email me at any time. Thank you. Have a great day.